Thank you. I should warn you, I don't often get applause when I'm going to lecture. I usually gaze out at a classroom of students who are mostly asleep and want to be somewhere else. The other first thing I want to do is to thank the people who've organized this, and thank you all for inviting me and for being here. I think this is, it's in its first year. I think it's going to really go places. I think it's very, very important. I also got some mixed messages about what to talk about. I got back from Australia a while ago because I'm cross-appointed to the University of South Australia. And down there, they're in a drought that in some places has gone on for 7 years. And this is a country that in 20 years will not be able to feed itself. And last year, for the first time, had to import wheat because its entire wheat crop failed. And I said, well, I come from a country with 20% of the world's fresh water, which is true. And I said, I'll tell you a little story about Tiny Township. And I told them about what may happen to and they could not believe it, because to them, water and gold are the same thing. So when I told Bill about this, he said, oh, well, you must come to the Elmvale Water Festival and talk about this. And then he began saying, well, you're a scientist in the center of this is education, so I want you to talk about water and the molecule and make it my favorite molecule. And then he said, no, that's going to be too technical. Don't do that. Don't show any equations. You notice he showed equations. So this is sort of a grab bag. And there's two things that I watch for in my audience. If people start nodding off to sleep, that's a sign that I've exhausted my time. But it's very easy for me to go over time, so if anybody would wave and say, shut up, I'll rush to the end. So let me get started and see, given the mixed bag of instructions I have, what I've put together. Oh, good, that worked. First, I'd like you to meet two elements. One of the great things about Western civilization is that we worked out that the world is made up of atoms, and the atoms are elements, and I think we're now up to 106 of them. But some are much more important than others, and I want to introduce you first to the most abundant, and that's hydrogen. And 70% of the visible mass of the universe is hydrogen. Notice I say visible mass, and I'm not going to talk about dark matter and the structure of galaxies as a result. Hydrogen, the lightest element, actually by mass, 70% of the universe is made of hydrogen. And here's an example. This is a supernova, the remnant of an exploded star, and there's the surrounding gas. 70% of that is hydrogen. By the way, our sun, to give us all the light we have, burns 1 million tons of hydrogen a second. It converts it to helium, but that's another story. So hydrogen, and the next element I want to introduce you to is oxygen. Now, Bill said, make this talk water my favorite molecule, but oxygen as O2 might be my favorite, and if anyone wants to know why, try holding your breath. Your brain requires 45 milliliters of oxygen a minute to stay alive. That's not uniform. We know that some people don't use their brain much and don't require much of it. But I thought I would show you what oxygen looks like. If you cool the air in this room down to a mere minus 180 Celsius, the oxygen would turn into a liquid, and it's a light blue liquid. So that's one of the elements I can show you what it looks like in some state or other. And if you put atoms together, and you get molecules. Some of the molecules are really big, and in terms of going to my favorite molecule, I'd like to talk about this forever. This is a protein molecule, and the reason why I would like to talk, there are lots of reasons, but one is that way back when I was a graduate student, and Napoleon and I were taking classes together, they used to say that we would never be able to analyze proteins because the molecules were just way, way too big. We had no way of handling them. And now we have begun to analyze proteins, and we know a lot about them. I have to tell you a little side story about that at a risk of overwhelming you. But when they worked out the human genome turned to be 1,000th the size of what they thought it would be. And the big question was, how do you start with such a comparatively small genome and make such a complicated animal as man? And the whole thing is the genome makes proteins, but the structure and function of each protein changes in your body, so that once you've got the protein, all kinds of things happen. And as a quick aside, The metals in your body are the proteins in your body are converted into the shape they are by the presence of metals. So metal ions, which are overlooked, things like antimony or antimony, are underrated. But we can put hydrogen and oxygen together and decide we'll make a simple molecule, and we can do it catastrophically. This is the Hindenburg. There you have 5 million liters of hydrogen reacting with oxygen, and the sole product of this reaction was water. A lot of heat to the dismay of anybody standing close, but basically an awful lot of energy. As a quick aside, if I may again, everyone who was killed in the Hindenburg event was killed by the burning of the diesel fuel. The hydrogen just went straight up. And you know, there are certain things make a real impression on mankind. If it's hot and flashy and it goes bang, that makes a real big impression, and you ignore what really happens. It's one of the many failings of our species. And here, when you put hydrogen and oxygen together, you get the water molecule. And we know an immense amount about the water molecule. I'll show you things about this that are astounding. We actually know exactly what the angle is between the hydrogen's bonded to the oxygen. And it's amazing that this is 104 degrees 45 minutes. A moment's reflection out there by anybody will show it should be 180 degrees. And the consequences of this are immense because of this very strange shape. Water, which should be a gas at room temperature, is a liquid. And it does all kinds of amazing things. I only wish I could get into the chemistry of this guy properly. We can represent it in various ways. The oxygen atom is much bigger than the hydrogen atom. We know the exact distance between the oxygen and hydrogen molecule, atoms within the molecule. And we can do all kinds of amazing things. And one that's totally unrelated that strikes me, with our knowledge like this, we can do things like measure the temperature of the surface of a star to within 5 degrees. So you take any remote star, we can tell you what the surface temperature of that is. And anybody who wants to know, it's the broadening of the calcium emission line. But you don't want to know, do you? Water has amazing physical properties. And here are some of them. The density is 1. That's the way, approximately 1, is the way we set it up. Melting point is 0 degrees Celsius. So think of it, we actually set up our measuring scale so that the freezing point of water we set as 0 on our scale that doesn't work very well, but, and the boiling point of water 100 degrees Celsius. And by the way, you can almost set, because that's what I'm going to say in a few minutes, you cannot have life, as far as we know it, with all our science today, you cannot have life unless you have water. And there's a lot of reasons for that. Very briefly, think, if I want to make a living organism and I've got a planet, and I've got stuff on it like water, I say, well, you know, it's a good idea to make this organism out of organic molecules. So I start building larger and larger organic molecules. If they're in water, they're not soluble in water. So they have to clump together. And that's how you get primitive cells. If the stuff was soluble in water, you'd never get life. You just get big organic molecules. And once they start to clump together, the cells figure that they need metals. They have to get the metals inside, and the only way they can do the metals is to get them from something which the metals are soluble, and metals are soluble in water. So you're gradually making up a circulatory system. I am getting carried away, aren't I? Anybody raise your... Yes, thank you, sir. There's nothing like a little honesty in the group. Well, what's so amazing about water? Well, you can't have life without it, and about 70% of the human body, I looked it up, as water. We just got to have it. And there's water everywhere. Turns out there is water in outer space. It's been detected in this same supernova here, and this is a galaxy. There are lots of water emission lines in galactic clouds. And comets, as we know, are mostly water. This is a picture of the Hale-Bopp comet, and I used to go out and look at it every night, and when it went away, I felt personally offended that it had left my neighborhood. But it's almost all water. And water's been found on the moon. Very excited, people got very excited about that. On Mercury, Mars, Neptune, Pluto, Triton, Europa, and various places. And of course, the reason they look for water is that you want to have any possibility of extraterrestrial life. As far as we know, there has to be water. And I guess Bill showed this picture. And it's one thing about NASA, their pictures are free. On the Earth, it looks as if there's lots of water, but as Bill pointed out, the bad news is there's actually not much. If the Earth was the size of a bowling ball and you picked it up, it would be perfectly smooth. You couldn't feel the mountains, and you wouldn't even notice that it was wet. So there's very little water, and all of it's on the surface of the Earth. Most of it's too salty to drink, and much of the fresh water is frozen as ice. Bill covered that, but didn't tell me he was going to. So I had nice pictures of frozen ice. And he did mention global warming, and this is my picture of global warming. I have other reasons for this picture. I used to look at the metals in tree rings, and we needed trees that were under challenged conditions, so they were up near glaciers. But this glacier took 4,000 years to get from there to there, and only 100 years to melt back. So if you have any suspicion that something is happening, there is evidence. Facts about water on Earth. Oh, yes, and some countries have a lot. That's the Amazon with its seasonal flows. By the way, the Amazon may not have that water for long, and there are complex reasons for it to dry up. But some countries have a lot of water, and countries like Canada. And because we have so much, I think we undervalue it. And that was mentioned earlier. And some water is polluted. And I thought I'd introduce you to the schistosomiasis fluke. You probably all know it as B. hazara. 40% of the population of Egypt suffers from this disease. It's a liver fluke. It enters your body through your skin when you go in warm, fresh water. And the building of the Ansuan High Dam was probably one of the greatest environmental catastrophes of the last 100 years. It provided the people of Egypt with a lot of shallow, warm water, and they're given to ritual bathing. So 40% of the population carries this, and it's a very debilitating disease. But there are lots of other things that pollute water, as people in Canada learn from Walkerton. And water quality is falling very dramatically. The water in Lake Erie is roughly becoming a disgrace. We use most of our water systems as open sewers. Some countries have a lot, and the bottom line is right now 18 countries in the world do not have enough water, and at the point where there are wars fought over water. So, and that number is going to go up as the water becomes less available and the quality goes down. And the effects of this are really dramatic. This is northern India. By the way, we've got to be careful. Crops, nothing has grown in this area in living memory. A few little scraggy trees. And in some countries, this is much more important. The biggest problem in India right now is the lack of trees. And because the trees are used to make charcoal for cooking. And if you're poor and it's dry and there are no trees, you don't cook your food. And if you don't cook your food, you've guaranteed a burden of intestinal parasites. And desertification is occurring world over. Things are spreading. And I came to talk about Australia, so let's say a few words about Australia. Australia is a very dry continent. Most of northern and central Australia is desert. Population is clustered around the outside, just as Canada clusters close to the US border. Heavens knows why. The Australians cluster close to the sea. And in Queensland is subtropical, so they get a lot of rain, sometimes too much. But 80% of the agriculture in Australia is sustained by the Murray-Darling watershed. This is Australia, and the Murray-Darling runs down through this part. This is essentially desert. This is possibly too wet, and this is where all the agriculture is. And for those of you who drink wine, that includes the Hunter Valley, and there's been a lot of loss of vineyards. And this is the Murray. It's the largest water system in Australia. It's the largest river, and by our standards, it's not all that much of a river. But you can take boat rides on it, and it's very, very attractive. Let me show you the Darling. Oh, that's another picture of the Murray. These famous sand cliffs and pelicans and stuff. And let's look at the flow. The average flow of the Darling was this incredibly large number here. By 2006, it had fallen by a factor of 10. By the following year, by another factor of 2, and the flow is now 1/20th of what it was. So the Darling is, the Murray is drying up. It's drying up very fast. One of the things at the mouth of the Darling is a place called the Coorong. And the Coorong is very important in Aboriginal legend. And it's where a great codfish, of all things, fought a human being in the great struggles, dug this huge basin. Well, the basin is salting up very rapidly. So all the freshwater fish and everything are dying because there's not enough flow out the Murray to stop the ocean from intruding. So one of the things they do all the time is dredge the mouth to try and keep the flow running. Let's take a look at the Darling today. That was one of the largest river systems in Australia. It's now a series of mud holes. And now we have to ask why this is happening. Well, believe it or not, of all countries in the world, one of the driest continents in the northern, in the upper reaches of the Murray-Darling system grow rice. So they have rice paddies, and they have cotton, one of the greediest crops in the world. And if you don't believe that, try and get some pictures of the Aral Sea. You will see fishing boats sitting on dry land, and that's because Russia took all the watershed that fed the Aral and used it for cotton farming. Downstream, demand is increasing because population is growing. And I was astounded in Adelaide in Australia when I walked in, when I first arrived. I took a look at the trees, and all of the trees growing in downtown Australia are Canadian Carolinian species, red bud and everything. And I said, you people are out of your minds. You have these huge, beautiful eucalypts, and they're amazing trees. I mean, I just love the suckers to death. And why don't you grow them? I said, because they're too damaging. And they said, the roots will find your water pipes wherever they are, and they'll drink your water. And then I found out the other hidden part they don't mention. The eucalypt's response to drought is to drop whole branches. And these are big trees. A branch weighs 3 or 4 tons. So if your tree is water stressed, it will show its disapproval by dropping a branch on your house. And by the way, you don't camp under them. It's very easy when you're out in the outback to say what a nice place to camp. You don't camp under a eucalypt lest it fall on you during the night. So population's growing, and that green lawns everywhere. I'd jog in the morning and there'd be water sprinklers going, with virtually no water. Control is fragmented. Now here's another thing. Australia has a system not unlike the Canadian political system where control for any resource is so fragmented, it's unbelievable. And the federal government in Australia has tried to decide to do something about the Murray-Darling, even though it may be too late. And they can't, because the states have so much power, the agricultural community has so much power. And I'm a great believer in farming and agricultural communities, but not if you're growing rice in the middle of a desert. My tolerance has some limits. A lot of the laws, as you can appreciate, were passed when there was a small population and plenty of water. So you have to change a whole existing structure. And these things are essentially out of date. There's a more important reason, and Bill touched on this earlier, and that's global warming. And I have to tell you, I was an opponent of global warming for a while, largely because it's the job of a scientist to be skeptical. And over a period of 20 years of studying it, I've become a believer. And, forget all this stuff. Terrorism, outbreaks of Ebola, bird flu, that's nonsense. Global warming's going to get us. Forget the small stuff. So I had to finish off somewhere. Knew that sooner or later the population would rise in revolt if I kept going. What's the message I want to leave? Well, there's limited useful water on the surface of the earth, very limited, and our population is growing rapidly. We know that water use is increasing exponentially. People love to water their lawns. It's another one of my pet peeves. I think the lawn is a terrible thing. We know we're changing the climate that's going to adversely affect the distribution of water. We know it's one of our most important molecules, not the most, but certainly it's right up there. It's in the running. It's competitive. And it's time to start doing something to protect the resource. And in Canada, the things that we're doing make me want to weep. having said all that, and think I've covered all the bases I was told to cover, and some I wasn't, I want to say thank you all for listening, and have a drink, but make sure it's of water.